heart of England's industrial north lies Rotherham, sister to Sheffield. Traditional centre of high-quality iron and steel, Rotherham is the home of many world-renowned iron and steel works. One of these, the Templeborough Rolling Mills, produces over 3,500 tonnes per week of hot-rolled steel in the form of rod. Of this output, 50% is used in the manufacture of wire rope, the remainder for wire netting, nails, screws, welding rod and concrete reinforcement. The raw material is straight carbon steel with a carbon content from 0.06 to 0.90. From the stockyard, the billets, each 2 inches square by 30 feet and weighing approximately 400 pounds, are conveyed via skids to the furnace charger, who feeds them directly into the large furnace. The furnace, heated by producer gas, has a capacity of 210 billets. The billets, assisted by push-down arms, travel down the sloping hearth, reaching a temperature between 1,030 and 1,170 degrees centigrade, the temperature varying according to the quality of steel. Having reached the required temperature, the billets are then pushed out to the other side of the furnace. The flow of billets into and out of the furnace is controlled by a signal operator. A hooter signifies to the charger and push-out operator when the next billet is required. They then pass through the roughing mill, consisting of 7 housings. Each housing reduces the steel size and twists it 90 degrees through alternate housings. Already the rod is being cooled, the water serving a dual purpose by also lubricating the fabric bearings in the stands. On leaving the roughing mill, the now 7/8 of an inch square rod passes through flying shears. The shears cut off the rough front end of each rod and also act as a safety valve. Should there be a hold-up in the mill, the shears cut the rod in short sections or cobbles until the supply of rod can be stemmed. This is the nerve center of the mill where the speed of production is controlled. Such control is vitally necessary where the speed at which the steel travels progressively increases from the first to last rolling. After passing through the intermediate mill, where the rod size is reduced to 3/8 of an inch square, the direction of travel is reversed by the first of 2 repeaters. Then to the pre-finishing mill, where the rod is again reduced in size and rolled from square to oval. The direction of travel is again reversed. The rod, now traveling at 60 miles per hour, enters the finishing mill. Here, the finishing size is resolved, which can be anything between 5/8 to 3/16 of an inch. Traveling in steel pipeways, the finished rods pass to the winding reels. Here, the rod, still red hot and some 2 miles in length, is coiled up and pushed onto the conveyor. After passing under 2 giant blower fans, the cooled but still very hot coils see daylight again. Considerable care is taken to ensure efficient storage and transportation. This changeover unit transfers the coils from the conveyors at the end of the production line to the bundle carrier. The bundle carrier takes the rod around the cooling dock for trimming, binding, checking quality and size, and labeling in readiness for shipping or storing. The enders trim off faulty ends and check the quality and size. The tallyman ties an identification tab on each bundle for sorting into different sizes. The bander puts the tie around the coil, the twitcher tightening it to hold the coil or bundle securely. With these simple but essential operations repeated every few minutes during 24 hours, continuous processing and preparation, the final shipping and storage operations require smooth, uninterrupted handling. This is achieved by transferring the coils from the bundle carrier to a specially designed boom arm with 5 bundles attached to each arm. As in all modern plants, the company employs forklift trucks with power units which will ensure smooth, uninterrupted lifting, transporting, storing and loading. These forklift trucks, all Perkins powered and fitted with special boom arm, a modification engineered by the Templeborough mills, are continually loading and transporting bundles into stock or onto waiting lorries. The efficient continuous process from heating billets of carbon steel to storing or loading the finished product is so smooth and rapid that the coils are still warm when ready for the lorry platform. As a precautionary measure, a steady jet of cooling water is directed on the still warm coils. Transport of all kinds is a vital link in the chain of mechanization and continuous flow. In these industrial applications, the Perkins P3 and P4 engines provide efficient, trouble-free service under continuous, arduous working conditions and at minimum running costs. Fine workmates to the men of steel who work the rolling mills of Rotherham. There's nothing quite like a meal cooked and eaten outdoors. It looks good, it tastes good too. What better way to start an afternoon's gliding? Ah, that's better. Now to get down to the serious business of pre-flight briefing. The Perkins Gliding Club is fortunate in having a ready-made airfield at its disposal. From this very runway, American fortresses took off on bombing missions during the last war. Unlike the giant fortresses which had powerful engines to thrust them skywards, these powerless aircraft have to be launched by a winch. The man on the bat signals all's well to the winch operator, and the first flight of the afternoon begins. But it's not all flying. Members of the club have to share the numerous ground jobs. One of these is operating the winch. Mounted on a Dodge lorry, this is powered by a Perkins P6 diesel engine. The P6 gives as many as 16 launchings per gallon of fuel as against 5 to 7 launchings with the original petrol power unit. The steel launching cable has to be retrieved after each launching. This is done by a Land Rover, also fitted with a diesel power unit, this time a P4. The adoption of diesel engines for both these duties is for reasons of economy. The end of the wire, complete with its parachute, is fixed on the rear of the vehicle. The Land Rover does as many as 50 return journeys over a 1,500-yard runway during a normal day's flying, traveling a total of approximately 86 miles. The Lasham Gliding Center uses a Jeep powered by a Perkins diesel engine for cable retrieving with considerable savings in operating costs. The cable is brought to the waiting twin-seater tutor. A pilot instructor is seated in the aircraft with a pupil at his side, preparatory to a training flight. No glider is permitted to take off without the controls and instruments being thoroughly checked. This is the responsibility of the pilot. The pre-flight drill is vitally necessary in order to ensure the airworthiness of the plane and the safety of club members. Once the pilot is satisfied that the glider is operationally safe, the launching cable is secured. The man on the bat signals for the winch operator to take up the slack. This is the moment the pupil has been waiting for, his first flight. Soon he will see the familiar aerodrome from an entirely new angle. Takeoff is smooth and graceful. It's too late for the pupil to change his mind now. Within a few seconds, he will be whisked into a world of comparative silence. At this stage, the glider is still linked with the ground by the solid steel launching wire. Of less than 1/8 of an inch diameter, approximately 3,000 feet is used in launching. The winch engine is operating at about 2,500 revolutions per minute. As the wire is hauled in, so the glider gains height. At 1,200 feet, the pilot pulls the cable release and the wire snakes its way earthwards, its rate of fall controlled by the small parachute. This tutor is one of 3 aircraft operated by the Perkins Gliding Club, which has a membership comprising approximately 40 company employees. These weekend flyers come from the offices and the machine shops, in fact, from practically every walk of Perkins activities. Aerobatics are not for beginners. It takes a competent pilot to do a loop like this. Already, more than 1/3 of the pilots are flying solo. Quite an achievement, since many of them had never flown before joining the club. The speeds at which gliders can be safely flown is apparent in this beater. At more than 80 knots, it streaks low over the airfield at the end of a brief but exhilarating flight. What goes up must come down, and landing a glider is a much trickier business than taking off. The speed of the machine has to be arrested before the landing approach. A slight climb, a sharp bank to starboard, and in she comes. Landing is assisted by spoilers located on the top of the wings. The chief instructor, who is holder of the United Kingdom local distance record, gives last-minute instructions to a lady member of the club before she takes off on her first solo flight. Another first solo flight is begun. This is another accomplishment for the club, an achievement for the pupil, and another successful launching for the Perkins P6 diesel engine. Colchester is the oldest recorded Roman town in England. Its fine castle, once the civic and military centre of the town, was built by William the Conqueror and has resisted the onslaught of military attack and the erosive action of time for nearly 1,000 years. The story of Colchester and its castle is told in the many relics and exhibits in the museum housed within the castle walls. The museum is strictly local in its exhibits and vividly illustrates the life and work of the town throughout the ages, with the emphasis on the Romano-British period. The castle walls are built of reused Roman bricks and septaria in alternating courses. These are supplemented by Barnock rag, quarried near Peterborough, the home of the diesel engines on which Colchester Corporation has standardized its entire fleet. Colchester is among the first municipalities to introduce diesel engines into low-mileage municipal vehicles, a field hitherto generally recognized to be exclusive to the petrol engine. The result has been a remarkable saving in running and maintenance costs. The wide range of vehicles and plant operated by the corporation today includes refuse collectors, road sweepers, gully emptiers, road rollers, dumpers, compressors, and a loading shovel. The reduction of cost in public services is all important, but it is not only through dieselization that the ratepayers' money is being saved. For several years, the collection of refuse has been paying its own way due to its profitable disposal. Kitchen waste is compressed hydraulically in the collector, so reducing the number of trips per day to the dumping ground. Waste paper and cardboard is stored separately on the trailer. Waste paper is unloaded at the refuse depot. After preliminary sorting, it is compressed and baled. This is later sold to paper manufacturers, and a considerable profit is made every year on its sale. Other types of refuse, such as scrap metals, are also disposed of for an economic return. At the dumping ground, the unsaleable refuse is dumped systematically in layers with soil interspaced to aid decomposition. The ground becomes quite solid after about 4 years, and within 10 years could be suitable as a building site. By this means, land which would normally be left waste can be reclaimed and once again put to some useful purpose. Apart from the use of diesel power units in the refuse collectors, amazing savings have been the reward of fleet standardization. The gully and cesspool emptier, for example, a very low-mileage vehicle, completes less than 8,000 miles per year and yet still justifies the initial cost of diesel installation. Statistics obtained from municipalities all over the country prove that the petrol to diesel cost ratio gives the diesel twice the number of miles per gallon of fuel. In addition, considerable savings on maintenance and improved performances are advantages worthy of consideration. The once high cost of road sweeping has been reduced considerably by the use of a mechanical orderly, powered by a Perkins P3V diesel engine. This vehicle covers on an average 20 miles of road a day. More than 655 municipalities throughout the United Kingdom have followed Colchester's example, with the result that today over 3,000 Perkins diesel engines are being operated in municipal vehicles and plant.